Hello guys, this is Lena from British Academy, and today I am going to explain you an example on geometric progression. So given that there are three numbers in geometric progressions, their sum is 21 and product is 216. Then we have to find those three numbers in geometric progression. First let us consider the three numbers of geometric progression as a by r, a and ar. So given that their product is 216, so let us multiply these three geometric progressions. So on multiplying we get here a by r into a into ar is equal to 216. So on the left hand side we can cancel our r and r in the numerator and denominator. On multiplying these three a's we get here a cube, and coming over to the RHS side we have here 216 and we can represent this as 6 cube. So therefore we get the a value as 6. Now we have to find the r value. So for that we have the other condition. The other condition is their sum is 21. So let us find the summation of the three geometric progression. So on adding we get a by r plus a plus ar is equal to 21. So we have here a value as 6. So let us substitute this value over here. So we get here 6 divided by r plus 6r is equal to 21. So this would come as 6 plus 6r plus 6r square if we take the LCM as r. And in the RHS side we have only one constant term, which is 21. Now let us cross multiply this. So this would come as 6r square plus 6r plus 6 is equal to 21r. Now let us transfer 21r to the left hand side. So we get this as 6r square plus 6r minus 21r plus 6 is equal to 0. So that implies we get this as 6r square, and by subtracting 6r from minus 21r we get minus 15r plus 6 is equal to 0. So from this equation we can take 3 as a common factor. Then the values that remains in the bracket is 3 into 2r square minus 5r plus 2 is equal to 0. So if you transfer here 3 to the other side, it becomes 0, and the equation would be in the form of 2r square minus 5r plus 2 is equal to 0. Now let us factorize this equation to get the value of r. So on multiplying here the quotient of r square and the constant term, we get here 4r square. Here we have the quotient of r square as 4, and we have the factors of 4 as 4 into 1. And if we add here 4 and 1, we get 5, which is the quotient of r. So we can write this equation as 2r square minus 4r minus r plus 2 is equal to 0. Now let us take 2r as a common factor from the first two terms. So we get this as 2r into r minus 2, and by taking minus 1 as a common factor from the other two terms, this would come as minus 1 into r minus 2 is equal to 0. Again let us take r minus 2 as a common factor from this whole equation. So we get r minus 2 into 2r minus 1 is equal to 0. So therefore we can say that r minus 2 is equal to 0, or 2r minus 1 is equal to 0. So by this we get the r value as 2, or 1 by 2. Now let us consider if r value is 2, then what would be the three terms of a geometric progression. So we have considered the three terms as a by r, a and ar. So let us substitute a and r values over here. We get here 6 by 2, 6, 6 into 2. So by simplifying we get 2 1 time is 2 and 2 3 times is 6. So we get the three terms of a geometric progression as 3, 6, 6 into 2 would come as here 12. And now let us consider our value as 1 by 2. We get here 6 divided by 1 by 2, 6 into 1 by 2. So on simplifying we get 2 1 time is 2 and 2 3 times is 6. And coming over to the first number, the denominator term 1 by 2 get reciprocal and it get multiplied with 6 in the numerator. So on multiplying 6 and 2 we get 12 as the first term, then we have 6 and then we have 3. So we observe that in both the cases the three numbers are 3, 6 and 12. So this is how we solve an example on geometric progressions. Hope you understood the concept. For any queries you can ask us through the comment section below. Have a good day.